Problem 6 for Math 112. The basic idea of these first 4 questions is to come up with the law of sines. Show that this thing right here is true. And the way you can do it, if you take as fact that the area of a triangle is equal to 1/2 times the length of 2 of the sides times the sine of the angle included by those 2 sides. So earlier in the class we referred to the formula as 1/2 AB sine C. You can come up with 3 different representations of the area of this triangle. So if you're using the side lengths A and B and angle C, you would say that the area is equal to 1/2 AB sine C. This is the more familiar formula from our class. However, you can do that exact same thing on side lengths B and C and angle A. It's just then the area would be equal to 1/2 BC. So playing the role of A is B and playing the role of B is C. And then it would be the sine of A, playing the role of capital C. And similarly, if you use AC and angle B, you got this 1/2 AC sine B. And if you make the connection that you can describe the area of this arbitrary triangle using any of these 3 measures, but it's just one triangle, then all 3 of these areas must be the exact same. And if all 3 of those areas must be the exact same, then 1/2 AB sine C must be equal to 1/2 BC sine A, which must also be equal to 1/2 AC sine B. This is the law of sines. Typically you don't see it written in this form, but this right here is equivalent to the law of sines. Typically it's written in this form. So how algebraically can I change this into this? Well, the trick to it is if you divide both sides, or I guess all 3 sides of this equation, by 1/2 ABC. So, okay, maybe I should take this in steps. Let's first multiply everything by 2. I got AB sine C is equal to BC sine A, which is equal to AC sine B. That's just so you don't have to write these 1/2s, right? You got all these 1/2s, multiply it all by 2, you get a prettier form. And then divide all these things by ABC. Why ABC? Because that'll allow me to cancel out a lot of stuff. So I'm going to recopy the line I have above here, but I'm going to divide all 3 sides, it's a weird thing to say, of this equation by ABC. And the reason I do that is then the A here cancels and the B here cancels, and I'm left with just the sine of C divided by little c. And the B and the C cancel, I get the sine of A divided by little a. And the A and the C cancel, and I get the sine of B divided by little b, which is our law of sines. So part 4, I was hoping you'd come up with the law of sines. Not that you really need to be able to derive or prove these things, but something like this that is within the reach of this class, I feel like it's interesting to do it. Maybe you disagree. Okay, so now I get down here to part 5. And for part 5, I think it'll help to draw a triangle. The triangle will look a lot like this. I'm going to just kind of arbitrarily throw A, B, and C here. And note that A is given to be 30 degrees. And side A is 10. And side B is 10 root 2. And I put side B opposite angle B. And actually, I'm going to change that a little bit so it matches up more with this picture, because I suspect that's what most students will do. So it really doesn't matter where you put the A, the B, and the C, as long as the corresponding sides are opposite those angles. But since I have this picture shown right here, I bet a lot of people put the A here, the B here, the C here, in which case the 10 root 2 is up here, and the 10 is over here. And we don't know this length. And the goal of this problem is to fill in kind of everything you don't know. So, okay, if this is 30 degrees, what's this? What's this? What's this side length right here? We've done this before. We figured out this angle. It was hard, but we figured it out. We figured out what C is and what B is. Maybe I'll even say this is A. How about I'll call this little C right here. But now that you have the law of sines, it's a lot easier. Because I could find, what do I want to figure out? Maybe I'll figure out B first. I can say that the sine of A divided by A must be equal to the sine of B divided by B, using the law of sines. And A I have, it's just 30 degrees. And little a I have, that's 10. B I don't have, but I'll be able to solve for that because little b I do have. It's 10 root 2. So as long as I know 3 of the 4 things in here, I can figure out the 4th using the law of sines. So to solve for b, maybe I'd multiply both sides of the equation by 10 root 2. That would give me the square root of 2 times the sine of 30 degrees is equal to the sine of b. This 10 root 2 goes up here, but I can cancel out the two 10s. I just get root 2 times sine of 30. Sine of 30 is 1/2, so I get root 2 over 2 is equal to the sine of b. So therefore, b equals, well, you're probably thinking 45 degrees, and you're right. However, b could also be equal to 135 degrees. All right, either of those will work. The sine of 45 degrees is root 2 over 2, but the sine of 135 degrees is also root 2 over 2. On your unit circle, there's a y-coordinate over here with the height of root 2 over 2, but there's also a y-coordinate over here with the y-coordinate of root 2 over 2. So either of those solutions work. So wait a minute, you got two solutions. How am I supposed to know which one I'm taking here? Well, in part 5, it says to find an acute triangle, meaning all angles are less than 90 degrees. So because it's acute, my answer must be this guy right here, that b is equal to 45 degrees. And once I know that b is equal to 45 degrees, I can find c. Probably the easiest way to find c is note that it does not say 45. That says 45. The easiest way to find c is know that the interior angles of any triangle have to be 180 degrees. So if this is 30 of them and this is 45 of them, I've used up 75 of the 180, meaning I have 105 left up here. And now I almost know everything. I just need to know what c is equal to. But I can figure out what c is equal to using the law of sines. Maybe I'll say that the sine of a, 30 degrees, divided by 10 is equal to, if I want to know little c, let's use the sine of 105 degrees divided by c. So I can figure out c because the sine of 30 degrees is just 1/2. What's the quickest way to do this? Maybe c equals c times the sine of 30 equals 10 times the sine of 105. Multiply this c up here and this 10 up here. But sine of 30 is 1/2. So you got 1/2 c equals 10 sine of 105. So multiply both sides by 2 to get that c is equal to 20 sine of 105. Sine of 105, that's not something we know at this point in the class. It turns out that's something you can get from your unit circle if you know some half-angle formulas. But since we haven't learned those yet, we'll just leave our answer like this. C is 20 sine 105. Now I have this, this, and this, this, and this. I've completely solved the triangle. Done with part 5. Part 6 is similar to part 5. It'd be a little short on room, but I think I can squeeze this in here. The only difference from 6 is that I'm going to go through solving everything the exact same, except b won't be 45 degrees. It'll be 135 degrees. And the reason why is because if I have a 135 degree angle and now have an obtuse triangle, and in part 6 I have an obtuse triangle, so in part 6 up here, I get that b is equal to 135 degrees. So really my triangle looks a little bit different now. Now my triangle looks kind of more like this. Let's try that again. Make it a little bigger so that you can see it better. Sure. Maybe not drawn perfectly to scale, but fine. Here's a right here. A is still 30 because that's given to me in the problem. Little a is still 10. Little b is still 10 root 2. However, now big B here, instead of being 45 degrees, is 135 degrees. And if this is 135 degrees, angle C up here is no longer 105 degrees. Because I got 180 total inside the triangle to play with. I've used up 165 of them, so only got 15 left. This angle right here must be 15 degrees. This is capital C, and this is capital B. So I almost have everything, right? If I could just figure out C, I'd be done. And I can figure out C same way I did over here. I can say that the sine of 30 degrees divided by 10, sine of 30 over 10, must be equal to the sine of 15 over c. This is 15 degrees now, not 105 degrees. Law of sines. So therefore, c times the sine of 30 degrees must be equal to 10 times the sine of 15 degrees. So 1/2, maybe I'll jump up here somewhere, 1/2 c is 10 sine of 15. So c must be equal to 20 sine of 15 degrees. And again, at this point in the class, we don't have the sine of 15 degrees. We can get it later using a half angle formula. But for now, we just call that good. Now I got all three sides and all three angles. So this would be my picture right here. And this would be the triangle, the obtuse triangle, that has one angle 30 degrees and two sides 10 and 10 root 2. All right, I guess that's all I got here. I'll end this video.